Okay, I mean, I know you guys are long break, so you guys probably don't remember how to do simple things. So x squared dx, everybody should be able to get this, right? Hopefully. Uh, Vincent's like, I don't know. X cubed over 3 is wrong. Why? Why is x cubed over 3 is wrong? Oh my goodness. Okay, so yes, you do have a plus c because this is a definite, this is indefinite integral. So you do have plus c because if you don't have plus c, you don't know if you need to evaluate for that c. So please understand that. Okay, so integration of x plus 1 squared dx. Just kind of review for you. What are you supposed to do? Thank you. Oh. And if you expand it now, you can integrate it, right? And don't forget about plus c because, yeah, if you got a value, the initial condition, then you want to find a particular solution. So if you don't have that plus c, you don't know looking for a particular solution. So yes, pretty important. Now, is this thing... Now, I'm just going to change you one question a little bit. So be x plus 1 to the 10th dx. Now, hopefully you're not going to tell me you want to expand this. Because if you expand this, you need something called Pascal triangle. And that big whole triangle is about just as big as a single sheet of paper. So you don't want to get to that. So it's got to be another way around. So this is the introduction of... So I'm going to introduce you what is U-substitution. Introduce the U-sub idea. So the U-sub idea is very, very interesting because one thing that you have to make sure is something to other than first power. It's good to use U-substitution. Now, can this question use U-substitution? Yes. Is the answer going to be exactly the same? Going to be different looking, but is it the same? Okay. So I'm going to show you how to do this. U equal to x plus 1. Why is u equal to x plus 1? Since integration, there is no other rule involved. For example, derivative, you got chain rule, you got product rule, you got quotient rule, you got all those cool rules that you can use. But integration is very limited on just U substitutions. Then what you're going to do is u equal to x plus 1. This is the first step. The second step is take a differential on both sides or derivative without respect anything. So for example, if I take a derivative of y equal to x squared, now if I do it implicitly, I'm taking derivative with respect to x. Does that make sense? That's going to give you dy dx, and this is 2x, right? Because d to the dx is not showing. Dx over dx, it doesn't need it. It doesn't need it. Now, if I take a derivative, if I do like a differential, is you're not taking derivative respect anything. So what happened is I'm just changing this u to du. I'm taking derivative of u, then I'm going to get du. Instead of say du dx, we're not taking derivative with respect to any variables. Now, this x is going to give you dx right here. So with that thing here, then you can convert everything in terms of u. So if x plus 1 is equal to u to the 10th power, and dx equal to du, now you got to make sure they are the same variable. If they are different variable, you cannot integrate. If they are same variable, you are taking the integration of u to the 10 with respect to u, then that's perfect. Now, if with respect to x, then that's no way. Got it? And then that's going to be u to the 11 over 11 plus c. That's equal to x plus 1 to the 11 over 11 plus c. And that's it, you're done. Now, the next question probably you're going to ask, Mr. Yeah, how do I know if this is right? How do I know if this is right? I just take an antiderivative. If I want to make sure that it's right, what will happen? I can go back. So if I take an antiderivative, what do you do to go back? What's the opposite of antiderivative? Derivative, good. Derivative, right? Can I take a derivative of this function? You take it down like 11, put it in the front, 11 times x plus 1 to the 10 over 11 plus 0, because the derivative of c is 0. 11 and 11 cancel out, x plus 1 to the 10th power. We know that's right. Got it? Yes.
So I know it would still be the same thing, but wouldn't chain rule also apply?
Huh?
Wouldn't chain rule apply here?
Yeah, but it's going to be 1. So thanks for reminding me of chain rule, because you do times 1. Question about this?
Wait, then why did we have to expand from what we did before? We could do it this way.
You can do this way. You can do u squared du, and that's equal to u3 over 3 plus c. And u3 is going to be x plus 1 over 3. Third. But except the answer is slightly different. If you pay attention, this is going to be x to the third plus 3x, I believe, plus 3x plus 1 over 3. This is all over 3 if you expand them. So the first term is going to be the same. Do you see that? The first term is the same. The second term is also the same. The third term is the same. Now, you didn't have the constant, but constant and 1 is going to add together. 1/3 and a constant, they are the same thing. So they are the same. But like I say, you might have a similar answer, but the constant is shifting a little bit, but it still result the same.
So
1/3 is not C, but you're gonna plus C, right? But eventually you have 1/3 plus C, but C is gonna be a little bit different, depends on your initial conditions. How do I take an integration of this? Now, we just go and do some easy one, so let's go to a little bit harder one. So what will be integration of something like, I don't know, x squared plus 1 to the second power, and there's 2x here, and there's a dx. So let's do it together. What would you set u as? What will be u equal to?
x squared plus 1.
Okay, good. You want to set it in a more complex one? Also, you want to say that u equal to higher power 1. You don't want a u equal to 2x. There is a reason why u equal to x squared plus 1. Do you see this relationship? Is 1 degree less. Now, why is that important? Let's take a derivative without respect to anything here. What will be derivative of u here? What would you get? du, good. What would derivative of x squared? What is it? 2x. And then dx? No, you're not taking integration. There was no plus c here, but there's dx, however. Am I going too fast?
Why is there a dx?
Because usually if you take a derivative of x squared with respect to y, right? But we're not taking derivative with respect to y. Let's say if I d to the dy like here, you're going to get 2x and the dy dx, right? But we're not taking derivative of this. We just take a derivative not respect to y. So you're going to get 2x dx. Oh no, so sorry, this is x. So 2x, sorry, this is dx over dx. Usually I don't write this down because it's just 2x. Am I going too fast? This one more step I usually do. Now some teacher doesn't teach it. I usually evaluate for dx. Get a habit of doing that because I enjoy to see something canceling. That's just me. So in this case, if you have u squared, because x squared plus 1, times by 2x, and remember, this dx need to change it in terms of du. Kind of important. A lot of people say that's overrated, but it's such an underrated thing. This one dx, if you convert to du, is going to be du over 2x. Now you see this would cancel out. Will be integration of u squared du. Am I going too fast? And it'll be u to the 3 over 3 plus c. And that's equal to x squared plus 1 over 3 to the third plus c. And that's my final answer. If you don't believe me, take a derivative of this. You should go back to before. There's a chain rule though, just like what? Now constant can take it outside. So integration of 2u squared du, what's the things that you have to do? You can take out a 2, right? The constant can be outside. Does that make sense? The next question requires you to know that skill. So let's just say integration of x squared plus 1 to the third power dx. I want you to do this. Remember, when you take integration, you can take out a constant. Let's see if you guys get it right. You guys got it? Yasio? Yasio? You got it? You're not. Your body's here. Mentally, it's not here. How many of you guys have done? Nobody? Remember, take a constant out. If you see a constant, multiplying by the expressions. You got u equal to x squared plus 1? Did you take a du on both sides? What'd you get?
du equals 2x.
Very good. Did you solve for dx? You should. So that is equal to x times u to the third. Dx is going to be du over 2x. Do you see that? Anything can simplify?
X and 2x.
X and x. This 1/2 you can spit out in the front. Does that make sense? I can just move it to the front. The constant can be moved to the front. Am I going too fast? No? U to the 4th over 4th times 1/2. So it's the x squared plus 1 over 8 plus c. I don't know if I did it right. Guess what? Let me take a derivative of this. So it'll be 4 times x squared plus 1 to the third over 8 times 2x, because if you realize that this would cancel out completely, it'll be x times x squared plus 1 to the third. Yes?
Wouldn't the plus c be like multiplied? Wouldn't it happen right after the integral?
Yeah.
So then wouldn't 1/2 also be multiplied by c?
1/2 times c is still c. C is any constant. You can multiply by 2, it's still c. You can divide by 2, it's still c. You can divide by 10, it's still c. Which is nice.
du, like,
Du integrated because you do integrate with respect to u. And that you have to have a du, you cannot have a dx. If you have u squared dx, that's not integrable. A lot of people does that. Am I going too fast here or no? Okay, I'm gonna give you two situations. Now you do realize, see that this relationship, right? Pay attention to this relationship. This is 1 degree less. You want to set u equal to the degree higher degree because usually degree less will cancel out. Okay, that's the goal. What time we get off here? Oh, we have 8 minutes. You should be able to do this in 2 minutes. No? Got it or no? Yes, Al? You're falling asleep? Wake up. Last night got it? Good. Amio got it? Cairo? Vincent? Oh yeah, Vincent. Why so slow? Quick, quick, quick. Did you do u equal to x cubed minus 2? Vincent? You did? You want to see, you want to do u equal to the higher power one.
Yeah, no. I did u equal.
U equal to x, not changing anything.
Okay.
I like now what you did. Du is what? 3x squared. So if I evaluate dx, it's going to be du over 3x squared, right? So du over 3x squared. And guess what? This thing will cancel out completely. Which is nice because that's u to the 1/2 power du. You can convert a power. So u to the 3 over 2, 2 over 3, plus c, 2 over 3 times x cubed minus 2 to the 3 over 2 plus c. Does anybody have any questions? This is good? Vincent, you got this?
Yeah.
You don't ever set u equal to x because it doesn't resolve anything. It is result exactly the same as before. It's all good. Don't worry. This is square to the 2 dx. Come on, you guys gotta be able to do this. Mhm. Vincent, what is u equal to?
U 1 minus u x squared.
Very wise choice. Will be du equal to
Negative 2 over 3 x cubed.
what? What's integration? What's derivative? Derivative of 1 minus 2x squared.
Oh, I did a derivative? Oh,
No, you're supposed to do derivative.
I did it.
Madeline, what you get?
Oh.
4x.
Yeah.
X.
There you go.
That's why I went, huh?
Okay, now I want to evaluate dx. So be dx is equal to du over negative 4x. Very, very important step because you're going to have negative 4x here. Do you see that can cancel? Exactly like this. So that is going to be u to the negative 2 du. U to the negative 1 plus c. So it'll be 1 over, oh, actually negative sign. My bad. It's going to be 1 minus 2x to the square to the first plus c. And that's my final answer. I know everybody got it correct.